Okay, so here we have three what's called isotopes of carbon. So we've got carbon 12, carbon 13 and carbon 14. They all have the same proton number. But this is the mass number at the top here, these three numbers, the 12, 13 and 14. And that tells you that even though they've got the same number of protons, they have a different number of neutrons, and that's what an isotope is. Something which has the same number of protons but a different number of neutrons, which is this number 12 minus this number. So in carbon 12 we have 6 neutrons, in carbon 13 we have 7 neutrons, and in carbon 14 we have 8 neutrons. Okay, so the relative atomic mass of an element is comparing the mass of the atoms of that element to carbon 12, the isotope we just looked at in the previous slide. So it is an average value for the isotopes of that element. So, for example, you may see chlorine in your periodic tables as 35.5. That's because there's more than one isotope of chlorine, and that number 35.5 is an average of the isotopes that are in existence of that particular element. And the same applies for the other elements in the periodic table as well. So we come on to the relative formula mass now, so something slightly different. So for example, if we take carbon dioxide, carbon has a relative atomic mass of 12, and oxygen has a relative atomic mass of 16. But we've got two of them, so we've got 2 lots of oxygen. So our relative formula mass is those two things added together, and so we do a little bit of mass, we get 12 plus 2 lots of 16, so that's 32 plus 12 is 44 grams. So the relative formula mass of CO2 is 44 grams. So if we had 1 mole of CO2, that big number of atoms that we saw in the lesson, you'd have 44 grams of it. But of course in this case it's molecules and not atoms, but the same principle applies. Moles can represent that many number of atoms or that many number of molecules, depending on what you've got. Okay, so we've already established that the relative formula mass of CO2 is 44 grams. Okay, so you should like to say the percentage of an element in a compound. So if you wanted to know how much carbon was in CO2, you would look at doing the following sum. Okay, so you would do the relative atomic mass of the particular element in question. So in this case we were talking about carbon, and you would divide it by the relative formula mass of the compound that you have. So remembering that carbon has a relative atomic mass of 12, and the relative formula mass of carbon dioxide is 44. So you would do 12 divided by 44, and that would give you a value of 27%. Now I've missed out a step there because I'm presuming you know it. To turn a fraction into a percentage you've got to times it by 100. Okay, and that gives you 27%. Okay, so now I'm going to talk about something called the empirical formula. So what it is the simplest ratio of atoms in a particular compound. So you could turn C6H12O6 glucose into CH2O, the simplest ratio of the atoms in that particular molecule. But what you have to do in the exam is to actually work out what that simplest ratio is from the mass as it may be given in question, or from percentages. So if you, for example, were given percentages as a question in an exam, then you would simply turn those percentages into masses out of 100 grams. So for example, you might have 76% lead, 13% chlorine, 2.2% of carbon, and 8.8% of oxygen. But you've got to turn that into an empirical formula of the simplest ratio of the atoms in that compound. So that's what we're going to look at now. So we've got 76% of lead, which we can just easily say is actually just 76 grams of lead. We can then say that 13% of chlorine, we'll just turn that into 13 grams of chlorine. And if we've got 2.2% of of carbon, we'll just turn that into 2.2 grams of carbon. And obviously the last one, 8.8% oxygen, will turn into 8.8 grams of oxygen. There's your first step. Okay, so the second step is to say, well, I want to look at how many moles there are. So we go back to that equation that you saw in the lesson that I taught you last week, or on Monday indeed, that the number of moles is equal to the mass divided by the molar mass, or just looked at in the video, the relative atomic mass. That equation is important. Here's how I lay out what I would do in an exam. Okay, I'm just going to do lead as an example, so I'll put a heading PB, ironically enough. Then I write out what I've got. So the first thing I'm going to put in is the mass. So the mass of lead that we said we had was 76 grams. And then I'm going to put in the next term, cross that bit out. I'm going to put in the relative atomic mass of lead, okay, which is 207. And now from the equation on the previous slide, so go back in the video, have a look at the last equation if you're not sure what I'm doing here. To work out the number of moles, I would do 76 divided by 207 and work that out. Okay, so that equals 30, effectively 37 or 0.37. Okay, 0.37. 76 divided by 207. That divided by that equals 0.37. Okay, then I'd have to go on and do it for all the remaining elements that I've got. So we had chlorine. We said we had 13 grams of that, and the relative atomic mass of chlorine is 35.5, or use 35.5. Now you could round up to 36. Do the same thing. 13 divided by 35.5. And you'll notice that also equals 0.37. What a coincidence. Suspiciously so. Okay. Now I have to do the same thing. I'm going to move the slide over. Make sure to follow, if you just cut back in the video to just track what I'm doing. We're doing carbon now. We had 2.2 grams. We divide it by its relative atomic mass, which is 12. And for oxygen, we'll do 8.8 grams and divide it by its relative atomic mass, which is 32. I might have to cut. And you'll notice that I've just made a mistake there, an obvious one. Sulphur has got a relative atomic mass of 32. Oxygen is in fact, as we all know, 16. So do those two sums again. It's almost as if that mistake was deliberate. So 2.2 divided by 12 and 8.8 divided by 16. So here 2.2 divided by 12 is 0.18, and 8.8 divided by 16 is 0.55. Okay, so I'm going to start a new slide in a minute, taking these numbers across, just so then we can see what the ratio will be. Okay, so we've got the moles from the previous slide. Now the trick here is to say, well, what's my lowest number? So my lowest number is 0.18, this number here. So I divide everything by that number. So I divide it by itself, divide 0.55 by 0.18, divide this one by 0.18, and divide this one by 0.18. Now what you'll find in the exam is that perhaps when you do these sums, they don't come out as exact whole numbers, but you should see a pattern emerging. So 0.37 divided by 0.18 is effectively going to come out as 2, as will this, as will carbon. It will come out as 1 because the number divided by itself is 1, and 0.55 divided by 0.18 is effectively equal to 3. So now what you've got is the ratio of each particular atom in that compound. So you've got 3 oxygens, 1 carbon, 2 chlorines and 2 leads. So we'd write this out to finish it off as Pb2 Cl2 CO3.